the entry is, of course, much different between the shuttle and the Soyuz. And the shuttle, as you know very well, it's like a glider. Comes back, you pull not much over 1G, and it gradually builds up to about 1G, and then maybe as you come around for the heading alignment, flying around the heading alignment circle to line up with the runway, and the shuttle, you may pull a little, almost 1.5 Gs. So it's a pretty benign entry, and then of course we land on the runway there. So it's a nice conventional landing that maybe we're all used to in an airline flight. A little bit steeper. It's a one-shot deal, but it's landing on the runway nonetheless. In the Soyuz, of course, you come in, as I mentioned, you pull about 4 times the force of gravity as you re-enter. The light show on the outside through the windows is the same in both cases, or a little bit different, but similar in both cases, where you start out with a light yellow glow, and then it gets brighter and brighter, and ends up being bright orange or red just outside the window as you come back through in that fireball. That's not a function of G's, that's a function of speed in entering the upper atmosphere. Consequently, pulling much more in G loading than the Soyuz, that entry phase happens much faster in Soyuz. It's, as I recall, about 10 minutes or so is all.
Particularly in this building, you will get lost. Trust me.
All right, guys, wave. What? See, show them how to do it. Here we go. You do the Tweetup wave.
Sean and Cassandra and Tina and Jay. Find one of us if you need something. So basically look to the back of the room and we'll take care of you. Let me introduce one of our flight directors. This is Mr. Ed Van.
I don't want to spend a whole lot of your time just babbling on and on, because anybody who works here could talk hours about how much they love their job and what they do. So I'll just give you a couple minutes overview of what we do in the Mission Control Center. And the camera cable also got wire tied and secured out of the way, so we've got full range of motion, pan and tilt on the camera on the orbiter boom. So we're I could be sitting at the EVA console, logging on the flight director, and I have to be on a mission.
We don't want him negative, so he's walking on the bottom. We don't want him positive, so he's floating on the surface. So we aim out to be neutrally buoyant. That's going to simulate the zero gravity environment they're going to experience on orbit. So we adjust weights all over the suit. And the trick is to get them in a 3-axis way out. So in orbit, you know, when they want to go invert on their head or they want to stand up or maneuver, it's very easy to do. But here you've got the viscosity of the water. You still have gravity playing its effect on the suit. So we adjust weights all over the suit to make it neutrally buoyant. Test director go through the process of buckling the waist bearing, putting on the gloves and locking them, putting on the helmet, and then we pressurize the suit to 4 pounds over ambient pressure on orbit at a 4.3. So we're very close to what they're experiencing on orbit. Once the pressure checks are good, the suit's holding pressure, the crew member's ready to go. We lift up the donning stand.
So I just saw that astronaut training that forward before I left.
Yeah, the Hubble stuff.
Oh, mine is
the weight of it was quite a bit lighter than the real arm, and all the mock-ups that you pick up, like if you're picking up one of the nodes there, like that was ready to do, it's filled with helium and it's neutrally buoyant in air, so it's very, very light. The windows all are, you know, they've got LCDs behind them, so it looks like you're actually looking down at the Earth and stuff like that. And you connect with Mission Control Center, so they can send commands, and you're talking with them on the radios. And after about 10 minutes of being in some of those sims, you think, like, other than the gravity, you think you're on orbit, because they're really very realistic.
Are they using the actual Mission Control Center?
Yes,
one of the
they do.
one of the
That's the one you use. You use the actual mission control center to talk with you when you're on those sims. Now, when there's a mission on like this, you can't really do that, and so you usually do standalone sims in there that you're not using the mission control center.
Who are you practicing for launch now? Are you talking to KSC?
No, we talk.
What do you hear?
We talk to this mission control is in charge.
Everything.
Everything other than the actual launch itself.
Okay.
And so when you're in the vehicle on the pad, you're talking to KSC, but this mission control is listening in. But as soon as the solid rocket boosters light and you clear the tower, they're in charge. So we're really mostly talking to them, and they're the ones that are really in control.
Their home being a semi-permanent habitat somewhere that they base their operations from. But they could go on day-long, week-long excursions with this lunar electric rover. Main part about it is it's electric. It uses solar power that they then store up and has access to wherever there's a source of a solar power panel.
Full-scale mock-up of the Skylab space station.
Well, these folks are
Yes, they
I think
are.
they tell 100,000.
Self-employed ambassadors.
Steve Robinson and Dan Burbank. Steve having flown on the 2 shuttle flights ago on STS-130, and Dan Burbank scheduled to go up for a 6-month tour on Space Station, September of 2011.
Committees to write what congressional
And
committees
there's
to
a
write
lot
to
of
people.
places out there. There's a guy standing at the back gate with a sign the other day, and I'm like, okay, you're fine.
Yeah, yeah. No, but actually, people on the Tweetup were looking.